Hello everyone, welcome to In 5 Minutes. In this video clip, we will discuss the working of third FM demodulator. Before this, we have discussed two FM demodulators, which were single slope detector, and the second one was balanced slope detector. In first demodulator, we use only one LC circuit, or only one tuned circuit in the process of demodulation, which had a drawback of non-linearity. So we move on to the second demodulator, which we call balanced slope detector, or sometimes you also call it a double slope detector, because we will use two tuned LC tuned circuits for the demodulation process. Even after using two tuned circuits, when we try to improve the linearity, we do not get perfect linear conversion from FM signal to AM signal. Let us go to the next demodulator and see how linearity can further be improved in this particular circuit. The third demodulator that we are going to discuss is called phase discriminator, or very famously called Foster Seeley discriminator. Please remember the concept of demodulation of FM signal. We first convert FM signal to AM signal. That means we convert frequency variations to amplitude variations first, and then we use diode detector or envelope detector, which works for detection or the demodulation of AM signal. Before we start with the circuit operation, we will discuss the principle on which the entire circuit is going to operate. I've taken two LC tuned circuits. That means one on the primary side, one on the secondary side. The input signal FM, which will be FM, the FM signal will be applied at the ends of the first, that means the primary coil. You can see there is a LC tuned circuit on the primary side and LC tuned circuit on the secondary side also. Secondary is center tapped, and hence we have three terminals coming out. This is exactly the similar structure we used at the input of the first two demodulators also. But in this case, we are going to tune both the primary circuit and the secondary circuit. Both will be tuned to the same frequency, which will be nothing but the center frequency of the incoming signal. Incoming signal being FM signal, we all know that the center frequency is nothing but the carrier frequency FC. So the incoming signal will be present at carrier frequency. There will be frequency variations above FC and below FC, which will be proportional to the magnitude of modulating signal. Now, let us see what is the principle based on which this circuit operates. Whenever both the LC circuits are tuned to FC, which is the center frequency of the incoming signal, and as you apply the input signal to the primary of the circuit, we all know that corresponding voltage will be generated across the secondary. If we have center tapped transformer on the secondary side, and if we have equal number of turns in the upper half and the lower half of the secondary as the number of turns in the primary, then exactly same voltage V12 will be generated across both the halves of the secondary. This time, instead of talking about the magnitude, we will be talking about the phase of the signal on the primary side and the signal that gets generated on the secondary side. So from the working of the transformer, there are three important points that we are going to use to discuss the principle. When the input frequency Fin is equal to Fc, the carrier frequency to which both the sides are tuned to, in that case, it is observed that both the voltages on the primary and the secondary side will be out of phase. That means if I denote phi, if phi is the phase difference between the signals on the primary side and the secondary side, will be equal to 90 degree. That means when input signal frequency is equal to the carrier frequency, the phase difference between input signal and the signal which is generated between ends of the secondary will be 90 degree phase apart. The second important point is whenever the input frequency goes above FC, that means when the input frequency increases beyond FC, then the same phase difference phi between the signal on the primary side and the signal on the secondary side will be less than 90 degrees. So it will go below 90 degree. And the third case that will occur will be when Fin, the frequency of the input signal, less than the carrier frequency. So if the frequency is less than the carrier frequency, in that case the phase difference between primary and the secondary signals will be greater than 90 degree. Now based on these 3 points, we will see how conversion from FM to PM can be achieved. So because on the secondary side we have center type transformer, we will define two voltages. The first voltage that we take will be with respect to point A, and the second voltage that we take is with respect to point B, because starting from point A I will have one envelope detector, and starting from point B I will have a second envelope detector.